Hi everybody, this is number 31 from the homework, and we want to factor the expression. So the first thing we look for is the GCF, greatest common factor. Is there something that we can factor out of all three terms? So looking at 12 and 10 and 42, they're all multiples of 2. We can factor that out. And then a cubed, a squared, and a, those are all multiples of a, so we can factor out an a. And then what we have left in the first term would be 6a squared plus second term we would have 5a minus third term we would have 21. Okay, so at this point we can consider this partially factored. Maybe it's fully factored. We'll have to find out whether or not we can factor 6a squared plus 5a minus 21. And you might recall me saying earlier that one way to check to see if a trinomial is factorable is to use the discriminant. And the discriminant is the inside of the radical in the quadratic formula. Let's see if I can talk and spell this at the same time. Discriminant, b squared minus 4ac. I talked about that if you watched the video for problem number 29. So let's calculate our discriminant here. That's going to be, so our a is 6, our b is 5, and our c is negative 21. So b squared minus 4ac is going to be 5 squared minus 4 times 6 times negative 21. And I put that into my calculator and I got 529. So I want to know if that's a perfect square. The square root of 529 is 23. So it is a perfect square. What that tells you is you do have something that's factorable. So let's go back and see if we can find the factors of that trinomial. Now from here it's going to be a bit of guess and check, because to get 6 you could try 2 and 3, 3 and 2, 6 and 1, 1 and 6. Just start with something. I'm going to do 3a and 2a. And then to give you negative 21, you could do negative 7 and positive 3, positive 7, negative 3. You could switch them around, 21 and 1. Okay, there's a lot of options, but remember, when you multiply the insides and the outsides, you should end up with plus 5a. So let's try to make some strategic attempts here that would give us just 5a in the middle. So what if we did 7 and 3? That gives us 14 here, and that gives us 9 here, and the difference between 14 and 9 is 5, so I feel like we're headed in the right direction. If we put plus 7, then we have a positive 14a, and if we put minus 3, we have a negative 9a, positive 14a, negative 9a, those add to 5a, so that worked. If you didn't get it on the first try, that's okay. You just keep trying the other possibilities until it works. And then positive 7 times negative 3 is negative 21, so it all checks out, and that's our answer.